Behind me is some of the highest and most rugged terrain in North America. And this week, the rough scientists face a truly mountainous task. Can they succeed, or have they peaked? Our 4 pioneering scientists are Ellen Macaulay, an intrepid go-anywhere botanist with a love of all things wild. Mike Bullivant, a chemistry wizard with a wicked sense of humour. Jonathan Hare, the do-it-all inventor, physicist and engineer. And Hermione Coburn, an earth scientist and explorer who never gives up. Their base is an abandoned mining mill way up in the mountains of Colorado. This is High Altitude Rough Science. The mill where we're based is on the slopes of Mount Kendall, one of Colorado's highest peaks. It dominates the local area, and it's about to dominate the lives of our scientists. We're at the edge of the largest collapsed volcanic crater in the world. Geologists have spent decades getting the measure of these mountains. Our scientists will have just 3 days. Their challenge is to get the mountain's vital statistics, and they won't have a helicopter to help them. Well, what a glorious sunny morning. Are you admiring our mountain? Isn't it gorgeous? That's Mount Kendall. It would be great to find out the height of it, but not just the height, also how much it weighs.
I think that sounds like a job for a botanist and a geologist.
I think you're right.
Do you really think that botany and geology is the key to this one?
It will be by the end.
Well, that sounds good. The other thing is, if it's going to be as bright and sunny and squinty as this, and we're going to be working on the mountain, it would be quite nice to have some sort of protection from the sun, boys.
Right, well, if we could find some sand, we could make some sunglasses for you.
That would be fabulous.
I'll help him.
OK, you said it, not me. You're now committed. You have 3 days. Let's get started. So Hermione and Ellen have to work out the height and weight of Mount Kendall. Jonathan and Mike are making me some surveyor's sunglasses, and Mike's committed them to making the glass lenses out of sand, something Jonathan still can't quite believe. Across the valley, the girls are considering the huge task ahead of them. How do you weigh an entire mountain? They've decided to start by sketching the peak to give them a better feel for what they're up against. Oh, it's a very peaceful scene. I have to say, sitting and looking at this mountain, well, it does seem impossible just looking at it here.
Okay, but first, the height really isn't that tough. All I have to do is boil water at the top.
But how would boiling water tell you the height of a mountain?
Well, the temperature at which water boils decreases as you go up in altitude.
OK, so that's easy.
Yeah.
All right. Weighing.
But yes, in terms of how much the mountain weighs, we need to know what it's made of.
I know what you're going to say. It's rock.
You were going to say that. But different rocks have different densities.
Right.
And it's the density that controls how much mass is in the mountain.
Right.
So what I need to do is get a handle on what rock types make up the mountain.
So you're going to have to go off, collect samples and work out their densities?
Yes.
And it also means, it sounds like you're going to need to know the volume of the mountain.
OK, because its mass of the mountain is the
Density times the volume. Exactly.
Right. So it sounds like, both from an altitude point of view and from a volume point of view, we're definitely going to need to get to the summit. I had a feeling you guys were going to drag me
You
up
are
there.
going to love it.
I am going to love it, and what's more, I'm going to race you. Let's go. If the boys are really going to make glass by melting sand, then they're going to have to generate the sort of heat you find inside a volcano. But Jonathan's still playing things cool.
So this is a wire with electrical resistance. And electrical resistance is something you don't usually want because you waste electrical power in heat. But in this particular instance, that's exactly what we want. I'm going to pass an electrical current through the wire and make it glow. A bit like the element in a toaster. It's going to get hot, and it's going to glow, and hopefully it's going to be able to melt the sand to make the glass. I'll coil it up and stretch the coil just a little bit so that none of the turns touch each other, and then I'll be able to wind it round something that we want to heat.
While Jonathan works on supplying the heat, Mike's in search of some sand.
very conveniently, there's some builder's sand here. It's been left behind. This sand is silica, or silicon dioxide, and it's the major component of that I need. Oh, this glass-making process is millennia old. But the thing is, I need to get it really pure, because any impurities in the silica will produce flaws in the glass. And so the next step is for me to get this back to the mill and purify it.
High above Mike, we're on the quest for the mountain's density. Hermione needs to work out what type of rock most of the mountain is made of. She can't collect every rock, so she's got to know which rocks to sample. And the key to that is understanding the geological history of the area.
Right. What's really exciting is that we're actually in what's known as a volcanic province that records some of the most explosive and catastrophic volcanic activity that the planet has ever seen.
I mean, when would have this happened?
This was all happening about 30 million years ago.
So what are you looking for?
Well, what I need to do is find the key rocks that make up the mountain.
Right.
And given the history of this area,
Yeah.
I'm actually expecting explosive volcanic rocks.
On her quest to determine the height of Mount Kendall, Ellen needs to measure the boiling point of water at a known height. So she's gone back to the railhead where the team were dropped off several weeks ago.
We know we are at Silverton and 9,302 feet. That is 2,835 meters, which means there's less air preventing the water molecules from going from a liquid to a gas, basically steam. So it escapes at a lower temperature. So what I want to do is get the temperature here and then go up to the top of Mount Kendall, find the difference, and we know that the temperature will decrease 3.4 degrees Celsius for every 1,000 meters. So I can do the calculation and know the elevation of that mountain. We have 92.8 degrees Celsius.
The difference between the boiling points here and on the summit should help Ellen calculate the height of Mount Kendall. Jonathan is hoping that his carefully coiled wire and a bit of electricity are going to generate enough heat to make glass.
Oh, that's gone. Okay, so that's far too little wire, because that burnt out straight away. That's 2.5 meters of the electrical resistance wire, and I'm going to put the mains across it. Let's try it. Okay, there's a nice bit of dust on there. Look at that. That's looking good. It looks very stable. I would guess that's probably about 1,000 degrees or somewhere approaching it.
Happy with his heat source, Jonathan's assembling his oven. He's found some old plant pots, and because they're made of terracotta, he thinks they'll survive the extreme temperatures. The furnace cement he's painting on will hold the coils in place. Mike's plan, to melt sand into glass, relies on getting the sand very pure, and that means a serious wash to remove any soluble bits, leaving the silicon grains behind. But not just any grains will do. Mike's very particular about the ones he's after. He wants fine sand, but not too fine.
If the sand grains are too small, then we get lots of little bubbles of gas in the glass that we end up with, and they're a devil to get rid of. So I'm just passing them through these two sieves. The bigger one will let. We'll take out the bigger grains, and the one underneath will contain the grain size that we want, because the small grains of sand have passed through.
Up on the mountain, we've cleared the tree line and entered geologist's heaven.
This, to me, is a completely different kind of geological environment, if you like. We've come up into a different type of rock that seems to make up a large part of the mountain up here.
It's very hard.
It's very hard! This is one of the volcanic rocks.
Right.
It's been formed by a whole lot of material and ash being spurted out the volcano.
Yeah.
great speed, really, really high temperature.
Yeah.
Flowing down the mountainside,
Yeah.
solidifying and cooling very quickly into this rock here. And the great thing is, I think if I can get the density of this particular rock,
Yeah.
that's actually going to give me a handle on the density of a large part of the mountain.
Because it seems like, well, certainly everything around us.
It all looks the same.
Seems to be the same, doesn't it?
Great.
Okay, well, should we press on to the top
Yes,
then?
and just go and check it.
Yeah. Let's pick that up on the way down. Don't
Okay.
take it up with you. We might be nearing the summit of Mount Kendall, but Jonathan and Mike are still at base camp with their furnace.
With a crackpot invention.
Okay, this is with zinc.
Which melts at 420
Yeah.
Celsius. Oh dear.
It doesn't look very hopeful. No, it's not melted zinc at all. We should be unmelting that easily, because it gets a lot harder.
And even when we've melted that, we've got a long way to go.
Yeah, that's the problem. So I think it's worth thinking about another design.
If he's ever going to melt sand, the next oven's got to be a lot hotter, which means getting the heat source much closer to the glass mix. High above him, Ellen's won the race and beaten us to the summit. But just how high are we?
Wow! What a fantastic!
You know
Take
the
a
rest.
breath. It's a beautiful view. Is that what you mean?
Yeah.
It's incredible.
Yeah. Well, you made it up here all right then. And you've got foliage. Fantastic.
Yeah. Hey, did you get the rocks you needed?
Yeah, we've identified the key rock types, I think. So
Cool.
that's good.
Yeah. So, what temperature are you boiling at here?
We are at 89.2 degrees Celsius.
Okay, and what was it in Silverton?
92.8 degrees Celsius. So that's a
Okay.
difference of 3.6 degrees.
3.6 degrees. Now, you know the height of Silverton.
2,835 meters,
Yep.
which means
Can't believe you're doing maths at altitude. I can barely breathe.
3,893 meters.
This is 3,893 metres, you reckon, from your boiling?
From boiling, yes.
Okay, okay. Gosh, that's a good start. So, Ellen's cracked the height of the summit, but now she has an even tougher task, working out the volume of the whole mountain. And that involves not only working out how wide it is, but mapping its entire shape. Hermione's checking that the top of the mountain is made of the same rock she found below. And I'm, checking Ellen's sums in my head. Now, how are the boys getting on? Furnace development, it seems, is not going well.
Oh,
The filaments can't take the power. But Mike's carrying on regardless.
Cookery time. The glass recipe. We need 100 parts of sand, purified sand, silica. We need 40 parts of washing soda, sodium carbonate, and 15 parts of crushed limestone. I could tint the lenses a variety of colours by adding different chemical compounds to them. So I've chosen to colour them blue, and you add cobalt compounds to colour glass blue. So let's mix these together, because the more intimate the mixture, the better the glass will create.
With the glass mix ready to go, Jonathan is concentrating on a new design, his Mark II furnace. But with every refinement taking hours to test, they're falling seriously behind, and it's only day one. He's still testing the furnace by trying to melt zinc. This late in the day, he can't afford to have any more failures.
oh yes, look at that. Hey, Mike. Look at that.
Is that zinc?
Yeah, that's the zinc, completely molten. You can see it's glowing red hot.
Yeah, it's more effective heating. isn't
Yeah.
it?
And you can see it's cracked, unfortunately. But I can overcome that. So I'll make another one of these.
Yeah.
I can put a bigger pot on top to insulate it. But I think this is the one that's probably going to work.
And because of the shortage of time, should we go straight to making glass tomorrow?
Yeah, we've got to.
They might have melted zinc, but to melt glass, they'll need to raise the temperature by 3 times as much. Daylight is running out, forcing the girls off Mount Kendall. They've still got a lot more work to do if they're ever going to survey this vast mountain in time. At the mill, the boys are taking a risk, combining elements from the 2 ovens Jonathan's built today. They're going to leave it running overnight in the hope of raising the temperature enough to turn their sand into glass.
And this was the Mark I furnace, which is heating up nicely. But I'm just using that as a heated lid. So
cool.
Not only are we stopping heat from going away,
Yeah.
but we're actually heating it from above as well. So we're going to get hot in there. We just have to leave it now.
Wonderful.
We have an oven which I know probably can get to quite high temperatures. I have no idea how long it's going to last for.
That mountain is taller than I thought. And I can't imagine what the volume's going to be.
It's tomorrow that I'm feeling a little bit worried about. I've got to make some quite accurate density measurements for the whole challenge to work.
As the first rays of sunlight strike Mount Kendall, Hermione is already building some equipment to measure the density of the rock samples she collected yesterday. And the boys are about to find out if Jonathan's Mark III oven, with its new improved heated lid, has produced any glass at all.
Are you ready?
Yep.
This is very, very nervous. Oh, look at that! Look at that! That's fantastic. What a beautiful colour.
Yeah, but they're frosted lenses, though.
If you can keep that going for 8 hours or for however long, you think that you will get much clearer.
It should be transparent.
Really?
With a hint of blue.
How lovely.
It's a good
I
start.
mean, you know, to get the very beginnings of glass at the very beginning of day 2 is pretty good going. Well done.
It's a fantastic colour as well. It's great.
In her bid to work out the volume of Mount Kendall, Ellen's building a scale model. She's measured how tall the mountain is and she's calculated how wide it is. But to accurately work out its volume, she's got to make a lot more height measurements so she can model its true shape. And with just 2 days to pull it off, she's come up with a shortcut. She's using the tree line.
So this is tree line. Above this elevation, too windy, too cold, trees just can't survive. You'll get little plants, but not trees. And this is the key to answering our challenge in terms of volume. It will help me make a model of the mountain so I can calculate the volume. So I want to find out what the altitude is. We'll do our little boiling number. Watch that mercury shoot up. 87, 88, 89, 90, 90.1, 2, 3, 4, holding at 90.5, 90.5. That's 3,511 meters. Tree line.
So wherever the trees stop, the height is about 3,500 meters above sea level. Using this information, she can quickly survey the height of large parts of the mountain without having to walk every slope. This should help her complete her scale model and work out Mount Kendall's volume. Jonathan and Mike, still high on their success of actually making glass, are preparing to re-melt it to get the air bubbles out. But they'll need even higher temperatures if they're going to make it fluid enough to shape into lenses. Using the rock samples she collected yesterday, Hermione is working on one of the key components of Mount Kendall's mass, its density.
The way it works is we drop the rock in this bucket.
Yep.
And then fill this side up with water. And we're just
Right.
working on the principle that 1 millilitre of water is close enough to 1 gram.
Oh, that's really clever.
So-
Nice and simple. And
Very simple. Okay.
woohoo!
We've got
Oh, too far.
No,
Gone
but
too far.
only just. So now we need volume to get the density. And that's just, again, a very simple method using water. The amount of water that the rock displaces
Yeah.
gives us its volume.
Right.
So just drop it in here. It's full to the brim.
It's so simple and yet so clever.
And just
One rock down and a whole mountain to go. All of Ellen's meticulous surveying and mapping has produced a 10,000th scale model of the mountain, and the amount of clay in the model should give her the volume of Mount Kendall. Getting a volume for a block of clay is even easier than for a lump of rock. All she has to do is squash it up into a nice, regular shape that's easy to measure. The weather has started to deteriorate abruptly as day 2 comes to an end. The temperatures have dropped sharply, which isn't good news if you're trying to make molten glass. The whole challenge now hinges on being able to pour their beautiful blue glass into a couple of moulds.
Just a little bit worrying. Ah, that's fine. It's all okay. I'm just hoping I haven't spilt the glass. Are you ready, Mike?
Yeah.
Wow! Wow, 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 look at that!
Stuck to the bottom.
Can you get it out? Be careful.
It's stuck.
Okay. Well, let's. Can we pick it up and pull the thing?
The whole thing.
Yep. Wow, it's really gloopy, isn't it?
It's like molasses. Look.
Is it
Molten
actually...
glass. It's not flowing.
It's
Okay,
not
put it back,
flowing, is
Mike.
it?
Put it back. Well, we've got the glass in there.
So you're not going to pour a mould from this?
It's not fluid enough.
No.
Right.
The temperature isn't high enough.
Oh,
We've got the glass there. But it's stuck in
how
the crucible.
frustrating. The glass challenge is suddenly looking as grim as the weather. Let's hope the double rainbow is a good omen for tomorrow.
It's glass, but with the temperatures we're getting, it's not liquid glass that we can pour.
And we're 1,000 miles away from making a pair of spectacles that will function.
It's day 3, and with the help of a bag of rocks and a lump of clay, Ellen and Hermione are finally starting to get some results. Jonathan and Mike, however, are a long way from my promised pair of sunglasses. The plant pot ovens keep cracking, and the only glass they've got is stuck firmly in its crucible. Is it salvageable in any way? I have to say it doesn't look like it, but do you think there's anything you can do?
Yeah, I think we just smash it up. Get all the blue glass out,
Yeah.
ignore the rest,
Yeah.
put it in the crucible and reheat it,
OK.
and then we can pour it out. Then we can cast it.
Mike sets to work salvaging the glass with a delicate touch, but their recovered fragments of glass will just stick to the crucible again unless Jonathan can get the oven hot enough for the molten glass to flow. With only 8 hours to go, this is definitely their last chance. Thankfully, the girls look like they're saving the reputation of rough science. Hermione has measured all her rock samples and arrived at an average density for the mountain, and Ellen's finished taking measurements from her model, so hopefully we've now got everything we need to work out a mass for our mountain.
Hey, Hermione and Kate, come here for a second.
What have you done to your lovely model?
What do you mean? I just kind of cut off the top and I filled in all the valleys.
Come on, what's the volume?
The volume is 13.5 kilometers cubed.
That is
enormous.
It's enormous. I can't even imagine that size. So, come on, Hermione, you've got the density.
Yes.
Put them together, we get the mass.
No, we don't. Well, I can give you an answer, but not the answer.
What on earth do you mean?
There's more to the mountain than meets the eye. So I just need to talk to Ellen,
Yeah.
do a few more calculations, and
Yeah.
then we're going to come up with a value for Mount Kendall in its entirety.
You haven't got long. I can't stand this any longer. So, there's still a missing measurement. It's a bit late in the day for an unwanted surprise. The success of both challenges hangs in the balance. With an even hotter oven, Jonathan and Mike are hoping that their recovered glass is now molten enough to pour into the moulds. If they're to complete the challenge, this attempt has to succeed.
Whoa, look at that.
that. Woohoo! Wow!
Oh, it's really gloopy.
It's so beautiful.
Oh.
Oh, look at that colour! That's fantastic!
Sticks to everything. But it's like very sticky toffee, very, very.
Now, is there going to be a way to polish it down, do you think?
Yeah, we could.
So we
I
can
mean, you
do
could make a sort of contact lens, couldn't you? Good luck, guys. It's looking fabulous. It's just not looking very clear. Now, what exactly did Hermione mean by there being more to Mount Kendall than meets the eye?
Now, just as an iceberg is predominantly submerged under the water with just a little bit poking out.
Yeah.
Well, a mountain is the same.
Okay.
There's much more to it. It actually has a root that protrudes right down into the earth. So they're
Okay.
not just what you can see.
Yeah.
They're not just the rock going down to sea level.
Yeah.
They actually protrude right down into the earth. What you have to imagine is this, the bit protruding above the waterline is
Yeah.
a bit of mountains that we can see.
Okay.
And then beneath them, you've got these deep roots.
Yeah.
And what you see here is the higher the mountain range,
Yeah.
the deeper the root.
Well, I shall look forward to getting the result.
I warn you, it's going to be a big number.
Ellen's got a volume. Hermione's got a density. With these figures, they can work out just how deep the mountain goes, and then calculate a total mass for Mount Kendall, root and all. Mike's got one hell of a lot of polishing to do if he's going to turn those blobs of glass into the surveyor's shades he's promised me. And Jonathan's only just started on the frames. Hopefully, somewhere in that blackboard full of equations lurks the mass of Mount Kendall. 'Cause time's up. Goodness, it's bright out here. I can't see a thing. If only I had a pair of sunglasses.
Ta-da!
Oh, those are brilliant. I don't believe you managed to do this after all that stuff.
Oh, yeah, they're very you.
I
They're
mean,
very you.
I can't see any glare through those at all. In fact, I can't see anything through them at all. Where are you? There you are. They're a magnificent achievement, but perhaps not ideal. I'm going to keep them on at this sort of slightly jaunty academic angle. Because, girls, this is now the time that we need to reveal our mountain over there, its vital statistics. Now, I have here a letter from a Professor Lang Farmer from the Department of Geological Sciences at the University of Colorado Boulder. And he has given me a height of Mount Kendall, but I'd like you to tell me it first.
Well, according to our boiled water, it is 3,893 meters.
And the height, according to Professor Lang Farmer, is 3,982.52 metres.
Hey, that's less than 100 meters out.
Less than 100 metres out. That's not bad. So it's boiling water versus the United States Geological Survey, and I think you've done pretty well, I have to say. Now, there is another number on this letter, Hermione. It's the weight of the mountain. Tell me what you got.
Well, bear in mind that it reaches down almost 50 kilometres below the peak that we can see.
Wow, okay.
We got round about 3.2 trillion tonnes of rock, but given a little bit of uncertainty,
Yeah.
Ellen and I
On this part.
are going to go for 3 trillion tonnes.
He says, according to my calculations, the entire mountain from its peak to the base of the crust should weigh 3 trillion tons. I can't believe it. Absolutely spot on. Gaze fondly at your mountain because you know it better than most. Well, they may be clever, but are they clean? Join us next week for a very special edition of How Clean Is Your Rough Scientist? See you then. For a free survival science pack and details of all Open University programmes, call 0870 900 9581 or go to open2.net, where you'll also find videos exploring more of the science behind the programme.